Dr. Musil, and in this video we'll be discussing truth functional logic. So we'll talk a little bit about what truth functional logic is, as well as the key or essential ingredients of truth functional logic. And so that's basically the plan for this video. Truth functional logic is sometimes referred to as propositional logic or sentential logic, and basically it's the logical analysis or breakdown of something that's said in terms of its truth value or its components truth value. So if somebody says something like, Sally will go, but Maria and Roger won't, right? The idea is we will translate that into logical claim variables and symbols and try to discern very clearly when that whole statement will be true based on the truth and falsity of its more basic components, right? Because we had three different people involved there. So when will that whole statement be true and when will that whole statement be false based on whether the three individual components are true and false, and of course how those individual components are related to one another within the overall claim, right? Because you might have an and involved, and that will refer to what we call a conjunction. You might have an if-then sort of statement, and all these types of words will indicate different logical relationships between the different component parts of the claim. So hopefully this will start to make a lot more sense as we go through the basics here, and then in subsequent videos also go through some more complicated examples as well. So again, though, truth functional logic, also known as propositional logic or sentential logic, and we tried to at this point sort of articulate what it is in general. So let's go ahead and move on to some of the essentials or the key parts of truth functional logic, right? So in essence, I think there are two major parts, right? And then of course we get to truth tables in order to depict, right, the truth values of what's being said. But these are really the key ingredients. We have on the one hand claim variables and on the other hand symbols. Using these two things, we'll be able to translate pretty much anything that's said into what I call logical notation. Logical notation meaning just claim variables and symbols and logical symbols, and that's it. So we can take anything that's said, for example, Sarah and Ralph will go, right? And we'll take that ordinary everyday sentence and we'll translate it into something like, right, simply logical notation, basic claim variables and symbols, and that's it. Okay, so the first thing I referenced, right, were these claim variables. What are claim variables? They're capital letters that stand for basic claims within what's being said, right? So the thing I mentioned, I think, was what? Sarah and Ralph will go, right? So there's actually two basic claims implicit in what's being said there, right? One, Sarah will go, and two, Ralph will go. Okay, so it's very important as you're doing homework and whenever you're doing truth functional logic to be as clear as possible, much like we did in chapter 8, right, when we symbolized different categories, when we were working with Venn diagrams and so on, we had to make a key. You want to do something very similar here when you're doing truth functional logic, right? So if S is going to be one of your claim variables, you need to very clearly indicate it somewhere, right, what S stands for, okay? So S will be Sarah will go, and R would be Ralph will go. Well, both of these are what we mean by claim variables, okay? So they're one of the two types of things we'll see in the end result of our translation into logical notation, right? Here they show up, right? The S and the R there, okay? And again, these symbolize, thanks to our key up here, that Sarah will go and that Ralph will go, okay? So claim variables, the capitalized letters that stand for the basic claims involved in whatever's being said, right, that we want to represent then in logical notation. Okay? The symbols are the other major ingredient, and we're going to be working with four basic symbols representing four basic logical operations, right, that are implicit in lots of things we say. And of course, these are outlined very well in the textbook. So just like they point out, right, we'll go in the same order that they go through them in the textbook. We have negation, which is symbolized. Actually, you can symbolize negation in a couple different ways. You can use either that symbol or you can do this. Both of those will mean negation. I'll use them interchangeably, so there's not really one I prefer more than the other. Then there's conjunction, right? So negation would be something like Sarah won't go, right? So look, to have a basic claim variable, you will never have negation involved in the basic claim variable, right? So it wouldn't make sense to put Sarah won't go up here. It'll be Sarah will go, and negation is an operation performed on that basic claim variable, right? So if what's being said is Sarah won't go, you would still label S as just being Sarah will go, and then you would symbolize it by employing the negation symbol and then that basic claim variable, okay? Or like I was saying, you could also do that, okay? Then we have conjunction, right, which is Sarah and Ralph will go. Or you might hear it put like both Sarah and Ralph will go, or something along those lines. And it's not just and, anything that's linking two different claims that are both suggested to be true at the same time. So Sarah will go, but Ralph won't, or something like that, right? That's also implying a conjunction. Okay, so anytime there's two distinct things that are being said that are thought to be true, that's a conjunction. And now I like to use this symbol for conjunction. There's also that's the wrong way. Part of the reason why I don't like it is because I can't do the ampersand. How does that look? Look on the computer here. Something like that, right? The ampersand. I prefer just the nice simple, what do you call that? A caret or whatever you would call that, right? That's the conjunction symbol. Either way works, okay? On the other hand, then we have the third one, which is known as a disjunction. And that's just what looks like a little V, right? And that symbolizes two different things, right? That will, one of which will be the case, maybe both, right? Or at least that's the implication of what's being said. So Sarah will go or Ralph will go. Joe will try out for the team or he will go to Las Vegas, right? So whenever there's two different possibilities being suggested, right, and the implication isn't they're both going to be true. They might both be true, right? But at least one of them will be true. That's a disjunction, right? Usually that's signaled by the word or, okay? So that is disjunction, and that's the symbol that we've used then for that, right? Or let's say our sentence was Sarah will go or Ralph will go. So it's something like either Sarah or Ralph will go, right? We would symbolize that then using our basic claims as S disjunction R. Either Sarah will go or Ralph will go. Okay? And then finally, arguably the most difficult is the conjunction, or not conjunction, the conditional, okay, which is represented by that arrow there. Okay, this is your typical if-then statement, right? So if I win the lottery, I will give you $1 million, something like that. So if Sarah goes, then Ralph will go. How we'd symbolize that is S arrow R. So that's the logical notation for if Sarah will go, Ralph will go, right? So we'd read it something like if S, then R. Okay. So that's it, right? Those are the two basic things we need when symbolizing whatever's being said in basic logical notation, right? Using only basic claim variables and symbols for these logical operations. So hopefully that's starting to make a little bit more sense. Just like a lot of things in logic, you start with the basics and then you have to have kind of a firm understanding of those because everything else builds on top of it. So this is no different, right? So if you're struggling with these basic things, you'll definitely want to, emphasize the beginning parts of chapter 9 until they become something you're comfortable with before you then move on to the subsequent parts of the chapter. Okay. The last thing I wanted to talk about, and I have quite a few things to say about this as well as truth tables. So what these allow us to do is represent all the different possibilities of the truth values involved in what's being said, right? Based on the overall truth of what's being said and the constituent parts of what's being said, right? So take, for example, Sarah and Ralph will go, right? So the idea is we can use a truth table to represent all the possible truth value combinations involved here, right? If let's say Sarah will go as true, but Ralph will go as false, well, then will the overall conjunction be true? It happens to be false in that instance, right? The truth table will depict all those possible combinations at a glance. Okay, so it's very useful. Presents an analysis of the truth values of the parts comprising a given claim or set of claims, right? So that it allows us at a glance to determine when the overall thing being said will be true and when it won't be. Okay? So let's talk about the basic construction of the truth tables. So first of all, the number of the rows that's involved in the truth table is going to depend on, and they talk about this, there's a little equation, I'll go ahead and write it up here, a little equation that they mentioned in the textbook, right? The number of rows is going to equal 2 to the n, right, where n is the number of distinct claim variables you have, right? So let's just focus on something nice and easy here, right? If we have 2 basic claim variables involved, right, so an n would be there, we will have 2 times 2 is 4, right? But let's say we threw in a third one, right, and we said Sarah and Ralph will go, right, but Quincy won't, or something like that. Quincy's involved somehow, right? So we threw in a third one. Well, this time the row number of rows would be 2 cubed, right? So 2 times 2 times 2, right, which happens to be 8, okay? And basically the gist of it is for each new claim variable you add, it's going to double, right? So if you have 2 basic claim variables, then it's going to be 4 rows. If there's 3 basic claim variables, it's going to be 8 rows. If there's 4, it's going to be 16 rows, 5, 32 rows, and so on. And fortunately, we won't really be dabbling with anything more than, say, I want to say 3, 3 basic claim variables. There might be, I can't remember on the homework if there's any that deal with 4. You definitely don't have to worry about 4 or more on the quiz. Okay, so we'll try to keep it relatively simple. But that is how you determine how many rows are going to be involved in your truth table. Okay, so let's go back to what we had here. Now, I guess I should start by saying, because a lot of people struggle with just this, what's the difference between a row and a column? And it's an incredibly important, point to keep in mind, right? You don't want to conflate row and column and confuse the two. For example, when you're suggesting something about a particular row that indicates the argument's invalid, right? You don't want to mean row when you don't want to say column when you mean row and vice versa. Okay, so rows go horizontal, columns go up and down, they're vertical. Okay, so I'm going to just jot some of this stuff up here real quick. So the things on the far left of your table, they're what are referred to as your reference columns. So the reference columns are always what's to the far left. The columns all the way to the left are known as your reference columns. What are in your reference columns are your basic claim variables. Okay, so if you have 2 basic claim variables, you'll have 2 reference columns. If you have 3 basic claim variables, right, you would have 3 reference columns. Okay. But those reference columns, it's important to note, right, they're just the claim variables without any logical operations performed on them or symbols involved. That's why I was saying earlier, right, if somebody says Sarah won't go, right, the claim variable itself is just S, it's just Sarah will go, and you'll represent Sarah won't go with the negation sign in another additional column. Okay, so you never have any symbols involved in the reference columns themselves. They're only basic claim variables. Okay, so let's say, right, so convention in terms of how to sort of outline the true and false underneath these, right? So we're trying to represent all the possible combinations of truth values for these constituent parts, right? So remember, we're dealing with Sarah and Ralph will go, right? So when will that whole thing be true, and based on when each of these is true or false, right? So what are the different combinations? Whenever you have 2 claim variables, remember you'll have 4 rows. That means there's 4 possible combinations of truth values for those constituent claim variable parts, right? So you always, on the far left column, the one you put to the far left, divide your rows by 2, right? And you'll start with half truths and then half false. And by the way, I like to use ones for true and zeros for false. And I would actually encourage you to do the same thing. You can use T and F if you want, but I've run into a lot of issues with not being able to tell the difference between a T or F. I call them TFs, right? So using 1 and 0, which is a very common practice in logic, you will avoid that issue altogether, right? 1 equals true, 0 equals false, right? So on your table, right, whatever claim variable you stick to the far left, right, whatever reference columns on the far left, it's always going to be half true on the top, and then the bottom half will always be false, right? And then the next column over will be divided in half. So if there's just two variables, it'll be true, false, right? But let's throw in real quick just so we can see what a 3-claim variable table will look like. Okay, let's pretend we had 3 basic claim variables here. Okay, well, I always start on the far left, right? You could start on the far right and just go true, false, and then go true, false, etc. I like to start on the far left. I know I have 8 total rows because there's 3 claim variables. So 8 divided by 2 is 4. I know I'm going to start with 4 trues and then 4 falses. And honestly, I always try to be as neat as possible, so I would encourage you, if you're doing this freehand, to just go ahead and draw lines too, so you keep all these in order. Otherwise, especially if you're one whose handwriting slopes, this can get really messy in here. So if I start on the left and I do the first half true, second half false, then I just divide by 2 whatever I did there. So I'll start true, right? I did 4 initially, so I'll just do 2 and then switch. So 2 trues, 2 falses, 2 trues, 2 falses. And then the last one's always going to be this way, right? Every other one's going to be, it's going to true, false, true, false, true, false. So what we've done is we've represented every possible combination of truth values for these 3 claims, right? All 3 of these claims, P, Q, and R, Paul goes, Quincy goes, Ralph goes, right? All 3 of them could be true. Or it could be the case that Paul and Quincy go, but Ralph doesn't. Or it could be the case that Paul goes and Ralph goes, but Quincy doesn't. Or it could be the case that Paul goes, but Quincy and Ralph don't. So on and so forth, all the way down to we've represented the instance or scenario where all 3 of them don't go, right? So again, that's what we're representing with these tables, is all the possible truth value combinations, right? When each claim is both true or false, what's going to happen with respect to all the other ones, okay? So that's the goal here. Let's see, what else do I want to mention? Mention the true false with 1s and 0s. So I'll just also say that, again, if you have a claim like Paul doesn't go, right, you don't ever put the negation over here, right? That's always going to be an additional column then, okay? So everything else that's built into the claim, you then have to start representing in subsequent columns, right? So any sort of operational symbol that's involved, that's going to come in then to the right of your reference columns. And that's going to merit or warrant, I should say, an additional column. Okay, so Paul doesn't go. Just real quick, I'll fill this in. We'll talk about the basic operational symbols in the next video, right, where I'll go through negation, conjunction, etc. in much more detail. But as we'll see there, right, it's just going to be the opposite of whatever the p-value is. So when Paul does go is true, then Paul doesn't go is going to be false, obviously. And when it's false that Paul goes, then Paul doesn't go is going to be true. Okay, and so on and so forth. And so let's say that we had something like, if Paul doesn't go, then Quincy will, or something like that, right? Before we could get to this, right, before we could represent this in a column, we've got to get the basic parts down, right? We had to get the basic reference columns of the basic claims. Then we had to do Paul doesn't go, right? Gets his own column. And now, and only now, are we in a position then to do the conditional. If Paul doesn't go, Quincy will. Right, and as we'll learn in the subsequent video, right, that's going to be true anytime the first thing or the antecedent is false, and so the conditional itself is always going to be true. Okay. just fill this in real quick. Okay, and we'll talk about why those are true and false in a subsequent video. Okay, so I just wanted to emphasize that what you start off in the far left, those are your reference columns. Those are only just going to be the claim variables, the letters, right? They'll never have symbols involved. And then as you're trying to get at exactly what's you started with, right? You'll employ those symbols then in subsequent columns, and you got to go step by step, right? Let's say this is part of a much bigger conjunction. So let's say, right, we actually had, so how would this read? If Paul doesn't go, then Quincy will go, and Ralph will go, right? Well, before we can get to all this, we had to first map out this part, which we just did, and now and only now can we then throw in this whole entire claim, right? This plus that second conjunct, which are, right? I'm not going to go through and do the truth values for that, but hopefully you see then, right? You got to do these step by step and start with the simpler parts, right? So then makes the more convoluted and complicated parts, right? The more the bigger part, the bigger thing, right? It'll make it easier to figure out its truth value when you've depicted all the smaller parts within it. Okay? I think the last thing I want to mention is, and this is especially important when you're doing your homework, you're trying to indicate, and we'll get to a video on this eventually, whether given arguments are valid or invalid using the truth table method, right? So you're going to eventually get using claim variables as the reference columns, as always, and then eventually you're going to get your premises, right, to correspond to certain columns. So let's say this was premise 1 and this was premise 2, and somehow this was the conclusion there, right? My point here is that I want you guys, again, trying to be as clear as possible, to always demarcate which columns represent your premises and which ones represent your conclusion, or which one represents your conclusion. So all you have to do for that is just clearly indicate it above the corresponding column, right? This is the second premise in the argument. This is the first premise, and this is the conclusion. And that'll make, and this is not actually the truth value, right? Let's just say it was this. Okay. That'll make then going through and deciding when this argument is valid or whether it's valid or not, right? We'll be looking for instances where both the premises are true and the conclusion is false, which actually row 1, right, would be such an instance, okay? That'll make that very easy, right? Because we'll know right where the premises are. We'll look for rows or scenarios or instances where both the premises are true and the conclusion is false, okay? Again, those aren't actually the truth values for that, but just wanted to give you an idea of how that'll work, okay? So it's important that you clearly indicate the columns that represent your premises and the column that represents your conclusion, okay? So in this video, we've talked about the basics of truth functional logic, the key or essential ingredients, and those being the claim variables and symbols, and then also discussed the conventions that we'll work with in terms of constructing the truth tables. Okay, so hopefully this video helped you, and we'll go ahead and discuss again some of these operational symbols in the next video.